Okay, it's time to start. This is just a funny thing from a full session. It's actually a game of tic-tac-toe. And if you cannot read it, the font in slide is much bigger. So, hi, what we have been waiting for. I'm Hana, and it's great to be here again after 3 years. No, third time, sorry, I'm nervous. I'm newly co-chair of Evolution Working Group in C++ Committee. I'm also chair of Reflection Study Group. And you probably know me for CTRE and also for CTHash, but I didn't present that. And in this for this talk, for library called CoCurl. And I love JavaScript. Yeah, by the way, I know the audience here can be a little bit cold. So I have chocolate here, and everyone who asks question will get a chocolate. Yeah, they are great, by the way. Anyway, so I love JavaScript, and when I was on committee meeting in Varna, I got a little bored one morning, and I wrote small thingy. Maybe you saw it. It's a search engine. Where's my cursor? Here. And it search in C++ standard and CPP reference. So you can like type thread, and it will search there. It's really quick because everything's happening in your browser and asynchronously with JavaScript. And you can also, do you know that C++ standard, there is a velociraptor? Well, let's see. Sorry. Velociraptor. There is a velociraptor. And it's here. Where is it? They removed the example first. Oh my. Okay. Anyway, that doesn't matter. Okay, let's move on. And this search engine works like this. It will download asynchronously parts of the index. It's reverse full text n-gram-based index. And it will calculate intersection, and it will give you nice results. And it's using fetch in JavaScript, like this. Await fetch some URL. It will give you a result of the promise, and you can work with it. You can extract JSON, text, whatever. How many of you know fetch in JavaScript? Please raise your hand. Okay, I will count with the general coldness of a Norwegian audience. So it's like more than half. Anyway, so you can also do this. You have multiple fetches, and you can have promise all and wait for all of the promises to be fulfilled and return like one common promise. And I think this is really lovely, and I want something similar in C++. I want to have fetch in C++. Because every time you see someone talking about coroutines or general asynchronicity or networking, in C++ it's mostly about sockets. Not even TLS sockets, but just raw sockets. And try to build something high level, maybe business logic with it. It's really hard. And I think it's not fair for C++. It's just, for some reason, C++ developers like to develop everything from bottom to understand everything. And I think it's not needed all the time. Yeah, we have async function, which marks the function which is asynchronous. Some name with the prefix, and we will download each files and yeah, wait for that and return the promise. So in C++ and C world, we have libcurl. How many of you at least once use libcurl? Okay, that's a pretty good number. So you probably know it. It's pretty simple API, and it's 27 years old. It's nice API. You have many supported protocols. HTTP, HTTPS. You don't need to care. You just provide URL, and it will give you what you want. It's really simple. So it looks like this. You initialize your handle with easy function. That is easy API because it's really easy. You will check if it's null because you need to do error checking, obviously. And otherwise return some like error or whatever. Then you set a URL to be downloaded. You will maybe allow to follow it to follow redirections if you want. And then you call perform, which will do all the I/O for you, and it will block you until it's finished. And if there was an error, you can print error, and at the end, you need to do cleanup. Typical C API, it's kind of nice and clean, and it maps really nicely to RII. So let's map it into RII. Oh, not yet. How do we get the output, not to the standard output, which is default behavior, but into, let's say, string? And we are going a little bit into C++ world now. So we have a string. We provide a pointer to the string through void star pointer because it's the API. And we provide lambda with some defined definition. And we take the string as a pointer to string and get reference to it. And every time we get some piece of data, we will just append to the string. It's not efficient, but I don't care. We are downloading from internet. So and return size, that's because it's needed. And then you provide the pointer to the lambda as a pointer to the library, call perform, and every time there is a piece, it will call your lambda and store data into the string. So far, so good. Same error, now with exceptions, because we are living in a more modern world. And at the end, return the string. If you have any questions, don't be afraid to ask, because it's going to be a little bit weirder. Yes, you want chocolate, yes. Huh? I omitted because it's just part. It's not like I'm not even initializing the handle here. But yeah. Sorry. Yeah, there will be some collateral damage. Sorry. Anyway, let's say the RII wrapper here. It's in namespace called curl. It's called easy handle. You provide constructor because every time you are also providing URL, so it should be part kind of constructor. So I made such constructor too. There is a destructor. I'm omitting assignment and copy constructor, move constructors. We have some options we can set later. So other URL again, follow location. Everything is typed and nice as a function, not just property with some opaque interface. And also break into, which is a template, which take any appendable container you can append it into. And there is a since perform, which is, I want to be visible that this perform is synchronous. So it will block you and it should be visible in your code. So this is highlight of the RII API. Okay, and fetch. So fetch will create the handle with constructor. It will set the redirection that we will follow redirections. We will provide the container to write into. We will call the since perform. If there is an error, we will throw an error exception. Otherwise, we will return string. I think it should be obvious. If not, we can redo it. Anyways, what I want to do is same function, but which will return promise and co-await for perform which is not synchronous. That's what I want. Because I don't need to write HTTP parsing, TLS handling. I just can use the libcurl for that and just write a wrapper around coroutines. And that's we have been waiting for. So, and at the end, we have the co__ keywords. I hate it, but it's something I can live with if I can get asynchronous programming in C++. So, scary coroutines. Coroutines were part of C++ 20, and there was coroutine TS before that. Why don't we have them yet? We have some libraries and so on. There's multiple reasons. Do you have any other reasons than these three? Sorry? Compiler support. There is for multiple years already some support, at least in Clang. If you are targeting multiple compilers, I can get it, but mostly people just target one compiler. I'm more backend person, so But yeah, that's good reason also. Some on Meetup last week, someone showed that Xcode didn't support coroutines until recently. Yeah, but now it does. So yeah, we can continue. But before I explain how coroutines in C++ works, let's say functions are just specialized coroutines. They are a subset of all coroutines, kinda, logically. So function usually have one starting point you call in, and they will start at the bottom or at the top. There is one entry point, and you can have multiple exits. You can have multiple returns, and you will never go back. And because they are behaving as a scope, lifetime of the members are really easy to think about. Functions look like this. You have a caller, which will call something and go back, call another thing, go back, call another thing, go back. Everyone knows the function. Maybe spaghetti, maybe developers from Italy. They don't like function because spaghetti development. But yeah, coroutines can have still only one starting point, but multiple entry points, because you can suspend them and resume them again, and you can continue in code which is there. And they can also have multiple exit points as a function. But the lifetime of the coroutine itself is defined by author of the library, because your coroutine can have lifetime of the caller, same as a function, but it can be like long-lived task living in background. It can be some like service which communicate with other coroutines. It can be a generator which is going like this. Actually, I have image for that. So you have caller, you will call generator, it will return immediately because it's lazy. And every time you resume it, it will give you some value, suspend, you will resume it, and it gives you suspend, and so on, like this. That's a generator. And at the end, when you no longer generator is not needed, it's just because coroutine is just an object. The lifetime of the generator will cease to exist, and it will destroy with destructor pretty cleanly. But if you are writing your own coroutine types, you are deciding what the lifetime will be. So coroutine looks like this, because that's one thing I got a lot. Coroutines are not threads. Some people, because some libraries will give you thread pool and task, and it seems complicated, but actually coroutines are things which are running in one thread. It's like preemptive multitasking. It's only your responsibility what will be scheduled and when, but it's still happening in one thread. So you can think everything is local. You don't need to log anything unless you jump into different thread. But that's not thing inherent to coroutines. Threads, on the other side, they are running in parallel. And whenever you're waiting for something, the thread is blocked. And it's responsibility of operation system to schedule it or wake later. But with coroutines, it's your responsibility to know what should be scheduled next, what should be resumed, and so on and so on. So in JavaScript, you have function divide, which is just a normal function which will take two numbers, check for the numbers, and throw exception and return value. Asynchronous function will look almost same, but there is the there is the async keyword. Otherwise, it's same. In C++, we have the weird co keywords, and they mark the coroutine. So when you use co keyword, co underscore keyword, the function will become coroutine, and also the return type of the function will describe define the behavior of the coroutine. In this case, it's same function. Either way, yeah, I do have error because you can provide minus numeric limit min for int, and it will give you, yeah, and throw exception, and at the end it will divide the number and return. The function int there, because coroutines are, if you use keyword, await, yield, return, your function is now coroutine. But coroutine also must have defined coroutine traits for your return type and arguments. But usually you don't need to specialize this template, because this template is created for you by default. And if your return type contain subtype, promise type, it will use that type, this promise underscore type. So you have like type name t arguments which are ignored, and it will take the promise type from the your return type and return the promise type to the compiler. But you can specialize these coroutine traits for your purposes. So you can actually take standard stutter promise and provide in your code make it coroutine if you want. Or you can have different promise type based on the arguments of the template of the coroutine. It's sometimes used to pass allocator, because you want to have allocator inside of promise type, not just in body of the function. Okay, but model of the coroutine, it looks like this. You have program stack, which is growing down, and somewhere there you have the function t, because I'm writing function which behaves as a coroutine which behaves as a function. And inside the function, there is a coroutine handle, which you can think it's just pointer, like void star pointer, pointing at coroutine, which can be allocated somewhere. It can be on heap, it can be on stack. Don't think about it much. And in the coroutine, you have resume point, which is a pointer to code, where the coroutine will be resumed next time when you call resume. And there is a function promise type, which can store like result, exception if you handling them, awaiter, scheduler. And there is a coroutine frame, which is frame exact size, which you need for your all variables at your in your coroutine, which will survive any suspension point. And yellow parts are your own to write. If you're writing coroutine, yellow parts are things you write. If you want to just use coroutines, you will write only the right one, and the rest will be provided for you by some library. But if you want to write your own coroutine library, you need to write these three, or first two actually, yellow blocks. I see people nodding, which is strong agree that people agree understand, so we can move on. Coroutine handle, just like to let you know how it's just internally just like void star pointer, has some member functions like destroy. Yeah, and it has like it's templated based on the promise type, or it can be polymorphic with void promise type. So you can have coroutine handle to any coroutine, or you can have coroutine handle for your special promise type. But otherwise, it can be destroyed. If you call destroy, it will destroy the coroutine frame and everything in it with promise type, and it will deallocate and do the cleaning for you. Resume will look at the pointer and resume the coroutine for you, and it will run the coroutine on your stack for variables which doesn't need to live like through suspension, but all variables which are on which will outlive the suspension will be on the stack frame or stackless frame of the coroutine. And then you have also done an explicit operator which will check if the coroutine was finished. It reached last suspension point at the end of the function, which is provided for you by a compiler. And then you have access to promise, and you can get promise from out of the coroutine handle, but only if the promise type is not void, because you cannot get a reference to void. And you can also build the coroutine handle if you have a reference to promise type. And you can also get just void star address and build coroutine handle from the void star address, because sometimes you want to interact with C API, like I do with Cockerel. Okay, and the function, the first type you as a library author you will write is function with some type, which is my return type, contains the promise type. I will get there later. Contains the handler type, which is stored because the function must own the the coroutine. Actually, this function behaves kind of like unique pointer. So the lifetime of coroutine is tied to the function lifetime because it's a function. So the function shouldn't exist if handle to it doesn't exist. There is a constructor which will take the handle and just store it. There is a destructor which will destroy the handle. And at the end, you can access the result value from the coroutine, or you can also use cast to the same type if you just assign int a equals function call, so you can actually use it as a function call. So how does suspension works? Imagine you have a lambda, and in lambda you have some captures, and you have one additional capture, which is the resume point, which will store pointer to address where it will be resumed. And at the start of the lambda function or lambda, it will always jump. Oh, sorry, there should be resume point. I changed this, change the text. It will jump to the label. So it will jump to state 1 when it start for first time, and then it will run some code. And when there is a suspension point, it will store the address for the continuation for the suspension after the suspension point and return from it back to caller. Let's pretend it will always return to back to caller. And again, it will go to and so on, so on. So every time you suspend the lambda, it will just store the address, do some cleaning, and return or jump somewhere. Okay, and each suspend point is marked with co-await in application code, or co-yield, because co-yield is just syntactic sugar over co-await. So more complex suspension is actually when you co-await on something, on awaitable, the awaitable is a type which must have 3 functions. One is await ready. So when you write co-await something, it will ask if the something is await ready, which means that there is something you are already asking for. If it's not, you need to suspend and do something else to get it later. So if it's not await ready, then we need to store where we will resume next time, when we will resume this current coroutine. If await suspend function of the something return void, we just suspend with current coroutine handle. So the awaitable can actually maybe pass the handle of the coroutine to some scheduler or to be awaited resume later. If await suspend returns bool, it gives option to the author to decide if it actually wants to suspend or not. So if you return true, it will suspend, otherwise it will continue. And if you return coroutine handle from the function, it will call the suspend, store the handle somewhere, and return another handle, and you will just jump there. So you can jump to different coroutine. So let's say I will co-await on something which I know will be done by other coroutine, and I know the handle. So I will just jump to the coroutine which will do it for me, and later I will be resumed here and after. And when I'm resumed, I will jump here, and there is third function, await resume. And await resume is called, and it will give me the result of the co-await. So if I write co-await expression, the expression will return awaitable, and the await resume from the awaitable will give me a result which I can assign to something or return somewhere. Okay, we in C++ standard we provide 2 awaitables ready for you because they are really useful. One is suspend always, which will always suspend, always return false. It's constructor. Suspend will just don't do anything. Await resume returns void, not doing anything. And suspend never will never suspend because it will return true. So await suspend is there just for fun probably. And await resume won't do anything, it will return void. These are 2, and they are really useful because if you just want to suspend and do something else with some scheduler, you just return suspend always. Co-await on it. Anyway, the function promise type has it's like customization point for coroutines, which sometimes scare people, and that's the main reason why people don't use coroutine more, because there is so many customization point. But when you start writing coroutines, you will find every customization point there is useful. You can something is for generator, something is for promises, something is for tasks. So every coroutine needs initial suspend and final suspend. Initial suspend is a point before you enter the body of your coroutine. You give opportunity to author to decide if the task promise will suspend immediately, it will be lazy, or it will never suspend, and it will be immediate. So you can actually run. In Python, you have asynchronous programming, which is lazy, and in JavaScript, you have immediate model. So you can actually do both here. And final suspend is when your function reach end of the body with exception, with co-return, or just reaching the end. You can suspend the promise to wait. So you can actually await, not await. You can extract the result from it, maybe, or the exception, or maybe you don't care because no one will waiting for you. So you can just never suspend, and when the coroutine reach past the final suspend point, it's not suspended. It will destroy itself and clean memory, and everything is cleanly removed. But it depends what you want. If you are writing some like background task, you will never wait on. Just destroy it. But if you're writing function, you want to suspend because you want to extract something from it, and you don't want to be destroyed. And then there is a function called getReturnObject, which will return the left one, my function of t from the promise type, which is available to user. In this case, I will just take handle and build. I will build handle from current promise type and return function, which is my type, to user. Then I have something to store the result of the actual function. And yeah, it's a slideware. So if it's not initialized or the t is not initial, like default initializable type, there are slides. And then you can also handle exception in coroutines, because if you call a function and throw an exception, user expect that the exception will fall off the function outside. So when you use co-return in the body of your function coroutine or coroutine function, it will actually call promise return value, and you can take something and store it inside promise type. But you don't need to store it. You can send it over network. You can log it. You can just throw it away. It's up to you as author. And there is another exception. So because the block of the function coroutine function is wrapped in try-catch block, and if you throw any exception, this function will be called, and you can take the exception pointer and store it to throw it later. But you can actually put there like stud terminate and just terminate the code because you don't care about exceptions. So, and there is the rest of the function. Same the constructor, destructor, and get will just check with assert if it's done. Check if there is an exception. If there is an exception, it will throw the exception out once you try to access it. Otherwise, it will return what you like the result of the calculation, the function. That's the function as a coroutine. Do you have any question before I move on? No? Okay. Yes. Let's say the example, we have divide function, which takes two arguments, and we kind of return function, and there is like it's slideware, so it's kind of like lambda, but it's like handle a frame which will be immediately like run. But I will copy the argument because these are always copied into the coroutine frame to be accessible because they will survive any suspension. And then I will call initial suspend and co-await it but my function will never suspend, so it's like no op. And then there is a try block. I will check for the that's the code I actually wrote as a user, the exception. And instead of co-return, I have return value a divided by b, and after the return, I will just jump to the finish suspension point. And there is also catch block, and if I catch anything which wasn't catched by user, I call another exception. And final suspend point will co-await on final suspend. So here you can decide if the function will outlive, or like if it will live longer until someone will take it from it, or you can just cleanly destroy it. It's up to you as an author. Okay, but that was function. So you can actually kind of build your model, but I need something more. I want promise. Like when you do asynchronous programming, you're promising something to user that you will return something. So promise, that's going to be confusing because I have promise and promise underscore type. So promise is similar as the function. There's some like constructors from handle type. You cannot copy it, but you can move it. And if it's there, you will destroy it. You can assign it. And the promise, like co-curl promise, is awaitable on its own. So you can actually await on the promise itself. So if it's ready, then we know that the underlying coroutine was finished. So if it's finished, then it's ready. And if not, it will call like await suspend. And what it will do, we will look into the promise and call function which is called someone is waiting for me. And who is waiting for me? Awaiter. And when something resume me, it will call await resume of return type T, which is the result of the promise. If there is an exception, because there can be, I will throw it. Otherwise, I will just from promise return the result. Okay, and the promise underscore type is just like inheriting from the function because it's similar with few differences. I'm storing also awaiter, the coroutine which is awaiting on me. So if someone is called co-await on my promise, I will just store handle of the promise there. So when I'm finished, I can actually jump there directly. And with initial suspend, I'm doing that is a nice trick. I will let my status as also some scheduler. I will let my scheduler know that I'm starting new coroutine. This is also like use part like interesting thing to do with initial suspend, and then I will never suspend. And in final suspend, I will return my custom final suspend type, which takes the reference to promise, and it will suspend. It will doesn't care resume, and when it suspend, I will actually let my scheduler know that I'm suspending this coroutine, and please select something else, and maybe this my promise awaiter is waiting for me. So I'm letting scheduler know that I'm finished, and maybe my awaiter is there. Maybe it's empty coroutine handle. And then I just return to the compiler, and it will suspend my coroutine. And there is a function someone is waiting for me with some other coroutine. I will just store it and ask scheduler to suspend and select next coroutine, because I cannot continue because what I'm waiting on is not ready yet because it was like so I need to wait for something happen. So I'm giving opportunity to scheduler to do something else. So when you called on handle for co-curl easy handle, you will call perform. It will give you lazy perform type, which is just awaitable with reference to the easy handle, and it will never be ready because you need to actually do some IO. And then when you suspend, you will associate the handle with current coroutine. There is like some like private pointer in curl API, and you just store a pointer to the coroutine handle inside of the handle. Too much handles, I know. You will store coroutine handle inside easy handle, and then you will ask scheduler to suspend and select something else. Or maybe the scheduler will return some, like maybe not. And then resume will return some result code, error code. Doesn't matter how it's done. It's like a little bit weird trick to do, but it doesn't matter. So we have caller coroutine, which will start coroutine. It's just normal call, and coroutine 1 will start, and until it's suddenly blocked, because let's say I ask to download some file from internet, so it's blocked. So it will suspend, and scheduler doesn't know what to do yet. So it will jump back to the caller, because the caller actually is not co-awaiting for the result. The caller doesn't care about the result yet. And scheduler will store the coroutine, so it's associated with it. Then I will start another coroutine, and it will do same. It will do some preparation, and then it will try to download something from internet, and it will suspend. I still don't care about the result, because I'm not co-awaiting. I'm just like taking, creating the promise, but I'm not co-awaiting in it. So scheduler will learn about the coroutine, and another coroutine, same thing. Okay, and then caller is going on, and then now I'm co-awaiting on the result of first coroutine. And now everything is blocked. Coroutine 1 is blocked, coroutine 2 is blocked, coroutine 3 is blocked, caller is blocked. If I know that number of blocked coroutine and started coroutine are same, I can actually ask scheduler, hey, complete something for me. Something needs to happen because I no longer can move in my code. So scheduler will do some I/O, and maybe some of the coroutines will start. In this case, coroutine 2 finished, but I'm not awaiting on it. So again, complete something for me. Coroutine 1 was finished, so it will return to the co-await, and I'm now co-awaiting on core 2, but that's done. So it's await ready. So I don't need to suspend now, and I just continue. And I'm waiting for coroutine 3. There are 2 coroutines and only, and both of them are blocked. So I will ask scheduler again to complete something. And only thing which can happen is something happen with coroutine 3, error. It will finish the I/O, but anyway, it will resume the coroutine 3 and continue, and that's done. Nice thing with this is you can actually prepare multiple downloads and then co-await them, and they will happen thanks to the library in background, in parallel, inside one thread. So scheduler, simplified, is a number of running tasks, or something, and number of block tasks. And every time you inform that you are starting something, you will increase the number of running tasks. When you final suspend some coroutine, you will decrement the number of running tasks, and then you will select next if there is some possible next. Maybe is, maybe not, because maybe someone is awaiting on the coroutine, maybe someone is not yet awaiting. If you suspend because you are awaiting on some I/O, you will just increment number of block tasks and ask for something else to run. And something else, like select next, will take the possible next. If there is possible next, it will unblock one coroutine and it will run. But if the number of running tasks and block task is not same, so in the call tree I showed you before, there is something else which can be done, probably because I just initialized. I will return no op coroutine, which is coroutine which will just work like return. It will go back to caller of current coroutine. So it's just like suspend current coroutine, go back, and maybe later I will resume the function, resume the coroutine. Otherwise, because the number of running tasks and block tasks is same, I will complete some I/O, decrement the number of blocked, and return the completed coroutine. And there is a function which complete I/O. And for that, I'm using multi-curl API, multi-API. How many of you use multi-API? Because, yeah, 1 person? 2? Okay. Easy API is really easy because you just create a handle, do some perform, and wait for it. With multi-API, you can actually add the easy handle inside of multi-handle. You can remove it also, and you can call multi-perform, which will do I/O for you on multiple handles together in parallel, asynchronously. And once something, and you can also pull on the IO on read and events from the network. And you can ask the library, hey, let me know which handle was finished. You can get multiple of them by multiple calling this function. So complete IO looks like this. It's an infinite loop. I will perform some IO like operation, TLS handshakes, whatever. And if something is finished, I will extract the associated coroutine from the raw handle, because so I will get the curl easy handle, and I will take the private pointer, convert it into coroutine, and return it. Otherwise, I will poll with maybe some timeout and do again. And so fetch. We will take URL. I'm taking copy because lifetime issues. I don't know. It can be problematic, and it's fine to allocate if you are downloading from internet, because the difference of time, like spent time, is odd. You can also specify number of attempts. You have like the output string, return promise of string. You will create a handle. You write into the string. You will follow the redirections, and there is infinite loop. If you have some attempt left, otherwise you will throw exception. Then you can co-evaluate on the finishing of the task or error, whatever. And if it failed, you can resume on the spot you download some amount of data, so you can resume if you want, and continue the loop with another attempt. If the response code is not 200 something HTTP, it will just throw the exception. Otherwise, it will return the finished output. And this is fetch in C++, similar as JavaScript one. You can have some also utilities. You can have like all, which will take range of promises and return promise of vector of the result of the promises. So you can have multiple promises for same type and wait for the download, and when it's finished, then hey, and you can extract the value type. Then you just, because sometimes it's useful to, when you're working with, the range can be like view. You need to materialize the view into something concrete. So actually the promise type will be created. So I create temporary vector of the from the promises. Then I will create output, which is the same size as the temporary. And for each temporary promise, I will co-evade and return the result of the promise into the output and return output. And it seems that it's like it's not parallel, but it's actually parallel, because the when I create the promises, they will start running, and they will be blocked by the dot perform. Then actually schedule can finish promises in different order, and I'm just waiting on them. But they will finish based on the size of the data and what you download or speed of your internet. So you can also have like optional. So if you have promises with returning optional, you will return optional of the vector of the results, and only if all of the promises will be successful. It's same. It's almost same, but there is a difference. You co-evade on it, and if it's null opt, you will return null opt for whole result. And funny thing is, it will cancel the promises nicely. So they will be destroyed in nice order. They will be disassociate from the multi-curl. There will be no leak. And return the output. So, and then to make it even nicer, you can create like a ranges interrupt by creating like it's still nibloid. It's still called nibloid. Yeah, nibloid, which is operate. It will take operator pipe of promises, range of promises with all tag, and it will do the same operation I showed you. And if it's the range of promises, optional promises, it will do same operation I showed you. And then you have like function. I forgot the name. It's a name. Name is all. So everything together. Question?
can we change, or maybe this is coming further along, but is the current design able to have an any function where you can be notified when one of them finishes?
There is a select. I'm not showing because it's ugly, and it will return first promise which will be finished from the set you provide, and the rest of them will be discarded. But there is also like in JavaScript, you can also like when something is finished, you will get a vector of promises, and some of them will be already like finished.
Exactly. Yeah.
Yeah. And catch.
Yeah.
I'm not good at rowing.
That's why I programmed.
Yeah, me too. So let's say we have a struct of resources, which contains URL and content. Then you have function fetch resource, which will take URL, return promise of resource. Resource is just like URL you downloaded from, and the content is just what you fetch. And then you have fetch all, which will take URL of some, let's say, web page, and it will give you a vector of resources. So you will download the web page. With CTRE, you probably should know CTRE because you know me. It will extract all the absolute link with HTTP or HTTPS from the web page. Gives you view of the link to the links. You will transform the links into promises with fetch resource. So when you actually iterate the range, it will start downloading for you. You will wait for all of them to finish. You wait on it, and you will return the result vector of all resources downloaded from web page. It's not recursive, but it will download all like linked resources from the web page if they are absolute URLs. Yeah, and that is like the thing I showed you at start, the search thingy. You have like something you are looking for with a number of number of results of the search you want to show. You will take ngram, the text, like you you are looking for the velociraptor. You will create a sliding window of the adjacent transform of 3 characters as an ngrams. You will enumerate them, so you will put also a position of the ngram in the input string, like 0, 1, 2, 3. Then you will take ngrams with some function. You will start downloading them from some URL. They are JSONs. You will parse them there, and also shift the index based on the position in the input string. You will get shards of the index because the index can be a few gigabytes big, but you will get just small shards of the index. You will sort them by size of the smallest shard to the largest one, and you will fold them from the left with first item there with intersection. So we'll do the intersection operation on the set of in the index. Then you will fold them again from the left. On the you will get like all the hits like across the data set you are searching for. You will fold them again with like document and not because you will get like document and place, document and place, document and place, and this will give you document and number of hits. Then you will partially sort them by the number of like results you are interested in. So and you will resize the result and give the result to users, and that's how the search engine works. And I have small hello world example. This actually works. Everything works actually on the slide. And you will download 1 second in parallel and print them. It will print hello world. And thank you. That's all. Any questions? I have a lot of chocolates.
Yeah, I have a question. What's the absolute minimum requirements for the run time here? Because can this just replace my task picture in my indemnity project?
Yeah, probably it can. You can just take the library and probably use it. Send me any bugs because it's just like kind of experimental. I actually learn myself the routines on it properly. So there were probably some bugs, but I use it in one like a work-related task, like job, like project I did, and I was like downloading like file from some server index JSON file with like links to the other files, and then download multiple of them. Then I create like a view which like join them together as big view. They will mapped in memory, and everything worked nicely. And it was able to download, I think, 400 or 500 megabytes per second quite nicely, and there was no leak. So it works nicely. So you can use it. Let me know how it works for you, and let me know if there is a feature you need.
I would need is a particular interpretation that doesn't use threads at all.
Yeah, you don't need that.
Yeah, and
If your platform has libcurl, if you provide your own like allocator for your types, you don't need to use heap at all. But yeah, if your platform supports libcurl, it will be fine. That's the question. But if you want to download from internet, you probably have something more like advanced than just like some like embedded chip with no system. Chocolate for you, and there will be collateral damage. Sorry. Anything else? Sorry.
the integration of the ranges library that have been included, or that was provided by standard library?
This small like dnibloid, I wrote my own. It's just like small struct which will just call the all function for me. But it's nice because I can just pipe it into all.
Very cool project.
Yeah. I did my own because it's really easy to do. Because I recommend people to try to implement some range algorithms or range view from the standard library from this draft, because actually you just copy paste most of the code from the standard and write few more like lines of code, and it will work for you, and it's good exercise, and that's how you learn to write this stuff. And chocolate for you. Wow. And question? Yes, you can see that, but with exception of lambdas, coroutines will gives you things which you before didn't have. Jumping somewhere else and storing state of the function. You could do it with lambda, kinda. Yeah, you can think about that, but it wouldn't be that nice. Yes, and I'm not going to throw that far away, so came here for chocolate later. Yeah. Anything else? I have a lot of chocolate, and we have time. Another question? No. Curl. Curl itself internally is doing something asynchronous, but in C world with like callbacks. But you can actually like write coroutines on top of that. I'm not using Boost ASIO because like Boost like focus on building everything from scratch from the bottom, and I don't want to like deal with HTTP and TLS. I have library for that which is like battle tested, and funny stuff. It's like currently working on 2 planets now. Yeah, you can do that if you want. I'm not doing that because I don't need that. Yeah, yeah, Curl provides you a lot of callbacks. You can have callbacks to like resolve of DNS. You can have callbacks to create socket. You can have callbacks to close socket, and you can like write like Curl with something like Boost ASIO, but why? Okay, anything else? If not, thank you for attending. It was a nice crowd and pretty warm.